I think that you could, oh, thank you, Shing. We could probably extract any region information necessary based on the topology, I'm guessing, but I am not enough of an expert on S3 to know all of the situations where the region really matters.
Okay, region really matters because having traffic, so everything is over the network. You can still access buckets in another region, but one of the main reasons to talk to a specific region is because one is if you're geographically distributed and you want to talk to the closest region, or two is for cost, where the cost of sending traffic, sending large amounts of network traffic over across regions is expensive. I think it's like 10 cents a GB or something.
Right. But I mean, all of those sound like topological concerns to me, and all of them would apply
Right.
equally to every protocol. So
And also
what
that
about S3 specifically cares about region?
I mean, also that if the admin cares about it, it can set it, and also the driver can push that to the downwards API so that the SDKs will use the correct one. But the question was about the bucket requests mostly, right?
So I did want to get into that particular detail. So I am aware that in the S3 signature algorithm where you generate the signature in the header, there is a field for region, and you have to say what region you're trying to talk to, and then that which region you put becomes part of your signature. So like it matters.
It's more than that. It's also the networking. Like this is how you choose the actual endpoint, for example, on AWS, right? This is how the client side knows to, right. So, but still, this is just this is a push down information from the driver mostly to the workload. But the question was like, do we want the users to be able to request the region, right?
Yeah. Or if we want users to be able to request the region, should it be through the bucket request, or should it be through some more abstract topology related field, like it is for PVCs and pods and everything else in Kubernetes?
Like a class, like in that sense, even, right? Even the class could represent like local region versus remote, or some, whatever the administrator has in mind for a topology tagging, right?
Yes. You can have a storage class that specifies an exact topology, and then when you create PVCs with that storage class, the system will require that the CSI driver supports that topology, and places the volume in the specific place you ask for.
Right. So that's the analogy for the cozy driver sending the region to the workload, basically, hooking up things correctly, like in the PVC world where you put the PV based on topology, and then you also put the pod schedule on the same node and things like that, right? So that's
but
like
none of these things require a field on the BR, right?
Right. Doesn't require, like, and that's the question of, do we see a user, or maybe the question is how burning it is for us to provide this capability to users at this point, right? We can always add it, but like how much do we really feel like the API is missing without it?
No, we still don't understand the feature completely. I'm not sure, in order to design it, will the API change? I mean, that's for sure, but like how fundamentally?
So I buy the argument that the downward API should have something like this, because the driver does know where it is, and the driver does get to specify the endpoint that the workload should talk to. And so if there are regional considerations there, they should already be built into the endpoint that you send. And then if for whatever reason you also want to include a region for the purposes of the S3 signature header, you could have that string get sort of pushed down to the downward API. But all of that, is from the driver back out. On the way in, which is what the bucket request is, I don't think you need anything more than a topology constraints, like either I don't care where it is, or I want it to be in this specific place, or I want it to be, in one of these lists of specific places, and like in general, the
But isn't
topology.
that in Kubernetes topology is bound to the cluster topology, right?
Yeah, like the concept of regions and zones have to make sense in the cluster itself.
Yeah.
And so, and they'll have different definitions. And if you're running like a GKE cluster, they're going to be Google regions and Google zones. If you're running an Amazon, I presume they're Amazon regions and Amazon zones. And then it always makes sense within where your Kubernetes cluster is. And if you're on-prem, you get to make up your own regions and zones however you want. If you want to divide your cluster by some sort of topology.
Right. But in the case of CSI, it only works because the CSI driver runs on every node. So each driver can advertise its own region. In our case, what do we do?
No, that's not the case. It's actually at the controller levels where all this happens. So when you do the create volume, there's an optional capability. Drivers don't have to support topology at all.
Topology constraints. Yeah.
But if they do, then at create volume time, you can pass in a topology constraints, which can include like hard constraints and soft constraints. And then furthermore, on the return value, you have to say where you
Kubernetes gives
actually
you
put it.
options. No, it's the other way. So when node driver initialization happens, it's the node server initialization happens. It returns the topology, and Kubernetes, knowing the topology up front to the create volume, gives you preferred and required list, and you have to choose one, like from required.
I think you have that slightly backwards. The Kubernetes node does know what its topology is, but the node plugin of the CSI does not. It has no concept of what topology it's in, because the topology is Kubernetes specific, not storage specific. And to the extent that
topology is defined.
They have
go on.
To the extent that they have matching of topology in workload and storage, it's typically you set your PVC to bind on first use, and then you create a pod, you allow the pod to get scheduled somewhere, and then Kubernetes arranges for the PVC to be created with a topology that matches where the pod already got put, if possible. And then that allows you to arrange for storage and compute to be close together. Alternatively, you can just have a storage class that forces the storage to be in a certain place, and then you can create the storage in that place. But and I think even the opposite is possible.
True. No, hold on. So I'm looking. Okay, let me just share my screen. What I'm looking at is node get info. Node get info. In the response, you get the accessible topology. That is, on that node, what's the topology there? And it's you can define it as whatever. You can use whatever keys you want. This is not Kubernetes centric. This is the CSI driver saying this is my topology, because the driver is the only one that can know what the topology is. Driver might talk to Kubernetes or might talk to an external system to find out what it should set as the value, but the driver is the one that advertises where it's running. Okay, and then Kubernetes will have awareness of it.
Yeah, I see what you're pointing to, and I'm looking this up because I don't remember this exact node get info. This is part of the CSI plugin on every node.
Yeah.
Get info. Hold on, my IDE is slow. I'm just trying to look up this code in one of my drivers and see what happens. Oh, come on. Yeah, it's just not fast. It's updating indices.
So what I'm getting at is, how do we even define the topology? Because if we don't know how to say these are the nodes which belong to, say, region 1, and because we're going to region 1, bucket should be in region 1.
Yeah.
How do we even define it?
Yeah, in my driver, this is left blank.
But are you using topology constraints?
Yeah. So I'm trying to figure out how this works.
Okay, do you want to share your screen?
Sorry, I'm switching drivers. No, I can't share my screen right now because I have too many windows open. It'd be a big mess to clean up my desktop. But I still assert that the topologies have to make sense within the Kubernetes cluster, and I believe that there
For sure.
must be an assumption here that somehow the CSI driver is topology aware
Right.
of the specific topology of the cluster that it's running in, and I'm not sure how that can be arranged. So just
I mean,
scratching my
it
head.
talks to the backend. It talks to, let's say on AWS, it talks to AWS metadata service and finds out what's the current availability zone, for instance, because you can't move EBS volumes across availability zones. So
But
it's
if this is node specific,
yep.
then how does the plugin know which node it's running on right now? Like, where does it get
Right,
that
right. Like,
information?
right. There's every cloud provider service or even OpenStack gives you this reflection kind of methodology where you can tell where you're running. So once
So
the
maybe
driver
the
responds.
expectation is the Kubernetes pod that comprises the node plugin
Mhm.
tells the node plugin which Kubernetes topology it's in,
Yep.
and then you just return that information right back from node get info.
Right.
So it's kind of weird. It's just like this strange loop back where Kubernetes tells you and then you tell Kubernetes.
Right. No, Kubernetes doesn't tell you. Sorry, no. Kubernetes doesn't tell you anything. You figure out what your topology is. You don't have to define it as
How
node
do you
name.
figure out what your topology is if Kubernetes doesn't tell you?
Okay, so I'll tell you. So I think what you're thinking is you're thinking the driver needs to give me back node names. Like it doesn't need to know anything about Kubernetes itself. Topology can be defined as any arbitrary key and value.
Right.
So
But like in a 100 node cluster, right, you have a daemon set that causes the node to be run on every single, or
right,
causes the plugin to be run on every single node.
right.
And when each of those node pods wakes up, it has the exact same state as every other one, other
Mhm.
than what Kubernetes tells it. That's the only thing that's different from one node plugin to another, is what, the
Kubernetes
pod
doesn't
that
tell
it's
it
running.
anything. No, Kubernetes.
Well,
So the driver's job is to talk to the backend, not Kubernetes, but whatever the driver's backend is. It could be the cloud, it could be whatever, and it talks to the backend, finds out from the backend who it is.
not the node plugin, because to talk to the backend requires having credentials, and node plugins typically don't have any credentials because that would be a security risk. Typically, node plugins are only involved with the attaching process. And so I'm really scratching my head here because the way we do this is we have our daemon set pass down the Kubernetes node name as one of the parameters to the binary that is the node plugin.
Oh no,
And that's how
you can start it with you can start the node plugin with these flags.
yeah. So I
And
imagine any topology information would have to be passed in through the same mechanism. Like Kubernetes would have to
downward
tell the
API,
pod.
downward
Yeah.
API,
The
just node name.
the pod downward API is how
Yeah.
Kubernetes would tell you where you are.
Yep.
And then that's
Yep.
the only information you have about where you are. So that's why I was saying,
Yeah.
like, Kubernetes tells you, and then you tell Kubernetes the same thing because there's no other source of truth.
No, but okay. Let's say there is some information Kubernetes couldn't possibly give you, whatever that might be.
Like I have to imagine that what it is there's some notion of like some plugins know that either they can attach to all topologies or only a limited number of topologies. And like that's where the difference has to come in. Because some node plugins is going to say I don't care where the storage is, like I can just mount it over the network, whereas other ones are going to say, hey, I'm a local disk plugin, like if the disk isn't on this node, like I can't attach to it because I only talk SATA or SCSI or whatever. I don't talk over the network. So like for those types of plugins, attaching to any
Right. I think this
topology.
is the reason why you need to tell Kubernetes, although you get the information from Kubernetes, but every driver would be like a node would parse it differently, right? Based on its
Maybe. Yeah,
architecture, right?
I'm not I'm trying to figure out how this works in practice because for the types of CSI plugins I'm familiar with, like iSCSI and NFS, it doesn't matter where it is. We're going to talk to it over the network. I mean, you may want it to be closer for performance reasons or cost reasons, but like if it's really far away, it can still work. It's just going to be slower and more expensive. Whereas with other drivers, I'm sure that it's make or break. It's like if you're in the wrong topology, you can't use this volume. Period.
Right. Right.
But when it comes to object storage, I think it's all the former, right? There's never going to be a situation where it's make or break. It's just going to be considerations about cost and performance.
I wouldn't be like completely sure about it, just because networking might also be so doesn't have to be fully connected, right? It's not that
Right.
you can always get to any service and everywhere.
Kubernetes networking has to be fully connected. Like every node must be able to talk to every other node
Internally, right?
typically. Yep. So there's no such thing as a Kubernetes cluster that's not fully connected.
But I mean, other services. I might have a service on-prem.
But that's not going to depend on which node you're on. That's just going to be either every node can talk to this service or every node can't talk to this service, right?
Yeah, it could be that this would be the outcome, but I'm not too sure that it will stay like this forever. Maybe that's my.
Oh boy, if we have non-fully connected Kubernetes networks or non-fully connected Kubernetes clusters, that'll be really exciting. Because
no, I'm not going that far. I'm just thinking about the external service, for that matter, like that you might want to have just several nodes being configured with the special networking needed, right, for that, for example.
Yeah. So what Guy is saying is it's similar to what iSCSI is. Like you're saying, you want to connect to an iSCSI network block device to
think about
a
fiber
node
channel
local to the rack. Yeah.
Available on only some of the nodes, right?
Right. Only within the rack. For instance, so we might have something similar with this too. I mean, a good example is cost could be prohibitive because of the scale of data to go across the region. So you have a strong hard constraint that you can only schedule pods in the same region for a particular bucket.
Okay, well let's rewind back then to the beginning of the conversation, which is, can we just copy what CSI has done with regard to topology and call that good enough? Or is there something special about block storage where you need something more than what CSI has done with regard to topology? That's what I was trying to get to.
Advertising the topology, that's the one thing.
Okay, so you're saying that some node component that knows topology information that's relevant to cozy.
Or we could say we use node labels. But in that case, in that case, the driver would have to be aware of node labels and would need to be.
We don't have a node component for cozy, so like whatever we're doing is going to have to be either part of kubelet or something you do at your node setup time, right?
Right. So you could say for a particular driver, or you could come up with well-defined labels. If it's set on the node, then we would be able to restrict topology based on those labels.
But isn't that how topology is today?
It is how it is, but except CSI drivers advertise it. We won't advertise it. We would just go based off of labels.
Yeah, well, and I'm still scratching my head on why CSI advertises it, given that it's already there. So that's a bit of a mystery to me. But
it doesn't matter, right, for our discussion.
Perhaps not.
Yeah. So we could just say we won't advertise it. We won't, and we just go off of well-defined labels. If a label starts with object storage.k.io or cozy.io or something / key equals value, then we use that as a topology constraint. And
I
then
think we would want to use the same topology constraints that the rest of the system uses.
What does that mean?
Well, I mean, the whole point of the CSI topology constraints is so that you can arrange for a pod and a volume to be close together. So unless the volumes and the pods are speaking the same topology language, that's impossible. Similar here, like we have to use the same topology language that the pods are using in order to arrange for a pod to be close to some
Right.
cozy bucket.
Right, but you're
So
not saying we
the
reuse the CSI drivers topology constraints, right? Because that could be custom, that could be defined by whoever.
not the constraints, but the labels themselves, the keys and values must be the same.
No, each driver can call it whatever they want.
I don't agree. I think that
No,
I
I've
think
seen
that
it in
if you
practice.
don't use the ones that the nodes use and that the pods use, then it doesn't work.
So that's right, but then the keys and values themselves could be defined by the driver. Could be anything.
But then how do you arrange for a pod to be close to a bucket if the cozy driver is making up its own
Right, right. The cozy driver would have to advertise it. So in the sense, not advertise
how does
it, they would have documentation. They would
how
have
does Kubernetes
documentation.
know how to put the pod close to that?
Oh, we'll need a component which I mean we'll need a way where the scheduling takes input from here.
Like a special cozy scheduler.
Yep, just like we have a volume schedule.
But the driver, I mean, what are we trying to solve here? The driver is the one doing the allocation, and the driver can check for, you know, the cluster location if that's the desire, or any configuration for the driver that will set my preferred region or my, you know, topology, whatever, a driver specific way of doing that. And then the driver can allocate the buckets however it feels like. But what are we really trying to answer here about the work, the
Yeah.
requests?
Because there has to be some common language that cozy and kubelet both speak when it comes to topology.
Why? Kubernetes is not doing the same thing in cozy that it does in
if
for
the
CSI.
outcome is that you want your pod and your bucket to be close together, you have to both schedule your bucket and schedule your pod. And if you're not using the same universe of keys and values, how can you arrange for them to be close? You're in separate universes.
Right. You can't put them
together. There's no
together.
Concept of close.
Right.
Unless you're in the same universe.
Yeah.
So there has to be the same keys and values.
So in cozy, also the pod will not start, will not schedule until the node adapter mounts the volume, basically.
It will schedule,
No.
and then it will get stuck. Or at least with PVCs, that's what happens. Is the pod gets scheduled, and then if you can't attach to it, then you're stuck there.
Yeah. No, but in case of cozy, what we're saying is, let's say there's a Kubernetes cluster that's across two regions, and you want to, you know, when you create a bucket, the driver says I've created in region 1, and so you want a pod that's going to use that bucket to also be in region 1. Now we need a common language between what's responded by the driver. So the driver needs to tell us in some way that this should go into region 1, and then Kubernetes should be able to understand that and use it for scheduling. So the question is,
can use the labels that are already on the nodes for that.
Right, it can do that, but the driver needs to know the labels then. Right?
Yeah, but that's usually a concern for the administrator to handle.
That's fair. That's totally fair. Yeah, that's fair.
I mean, the admin has to feed that in somehow at start, you know, when he configures the driver.
Or it can be values that the driver is already assumed to understand. So the driver could say, I understand labels starting with this prefix.
Yeah.
Yeah, and then yeah, and then the driver responds with the you know, while scheduling, the driver would have to respond saying that this bucket belongs in this region, and then it gets scheduled to that, you know, that node.
But they're the same labels that Kubernetes is using to schedule the pods.
So
we want what we're trying to do now is to have cozy affect pod scheduling in order to optimize the pod location for the bucket, right?
Exactly.
Yep. I would, yeah, it's not even optimization, it's a requirement probably.
No, I'm not saying it's not. I mean, it is an optimization for sure in many cases,
Right,
and in some cases it's a must, right? I agree,
Yeah,
but
yeah.
Do you guys feel like it's a must for the API at this stage? Because and like my sense for what we're doing right now is that we can stop at around this point where we say it's Cozy doesn't define this,
Well, yeah,
and
well, I
we
feel
will
like
define it.
we can copy what CSI did and say, there's a capability that drivers can opt into or opt out of. So if a driver doesn't want to implement this, they can just not assert the capability, which means we're not going to do topology-based scheduling. But if they do, we can do exactly what CSI does and have allowed topologies get passed into create bucket and actual topology or accessible topologies get returned from create bucket. And that's all you need. If you have a constraints passed in and accessibility passed out of your create path, you're done. And
That
you can
actually
make it
sounds
optional by
pretty.
wrapping it in a capability so the drivers can opt out if they don't want to deal with it.
And I'll tell you why it sounds reasonable, because the bucket location itself is actually doesn't matter. Like the only thing that matters to the driver is to choose correctly the topology for the pods that access it. It doesn't really care if the region for the bucket is called the US East 17 or US East 16, right? It just has to really.
It could matter if your
Right.
Kubernetes
Yeah.
cluster is in a specific region. You want all of your buckets to be in the same region, and the driver itself might be capable of putting your buckets in all of the regions. And so it needs to be told, like, hey, this Kubernetes cluster is running in region 16. So please put your buckets in region 16. All of them, right? If the whole cluster is in that region, then there's no point in creating buckets in any other region.
Yeah, but then it becomes the driver's role to implement that request, that optimization or whatever, like request. But from Kubernetes perspective, Kubernetes only knows topology, which is a Kubernetes cluster topology, right? Nodes
But
and
I'm
their.
asserting that Kubernetes cluster topology is the same as the storage topology, because if it isn't, it's not useful. Like to the extent that you have topology, it has to be the same keys and values to be meaningful.
Like give
Yeah,
me
yeah.
Mhm.
I think so. Just to wrap up on that, my thought process is that I agree with you that Kubernetes needs to understand the topology of the access, right? It needs to know that these nodes can access a bucket on this region, but well, it's not Kubernetes
Well,
that knows it. Actually, it's only the driver that has this notion.
but
Kubernetes
to be
itself
clear,
doesn't know
there's
that.
the topology constraints that exist in the CSI side. There are two levels. There's hard constraints and soft constraints. So like hard constraints means like if it's not here, it will literally not be usable. And soft constraints just means like we would, while it's usable
Preference.
everywhere, like we prefer it to be here because it's better for some reason, right? Whether it's cost, whether it's performance, it's your ability to express a preference. So those are the two levels. Is there's the hard constraints, which means if you put it here, it literally won't be accessible, and then there's just if you put it here, it'll be suboptimal. And you can pass both of those in with CSI today. You can have hard topology constraints, soft topology constraints, and then after you've picked a place for it, you get to tell Kubernetes, hey, I put it in region 16. Use that information as you will, right? So that if the pods are flexible and the storage is not, you can move the pods to where the storage is, and vice versa. Depends what your degree of freedom is, and the admin and
Sounds
the
good to
user
me
are
to
expected to
try
know
that.
that.
It sounds good to me to start with this notion, because I think that it doesn't really matter the actual region of the bucket, to be honest. Like the fact that AWS, for example, has a fixed number of regions for that for buckets, say, doesn't really affect how the Kubernetes cluster looks at its own resources, and the driver can map these bucket regions differently to the cluster regions, right? The cluster topology, however it wants to. It's the driver decision basically there. It's not that Kubernetes asserts, okay, it has to match by name, that the bucket and the pod has to have the same topology label on them or something like that, right? So
Well,
basically what we're saying here is that the
but
driver just needs to allocate the bucket based on these topology, based on the topology information that is in the cluster, right? Saying these nodes, these labels, etc., and then map that to the bucket world where it might be completely different topology names and regions and availability zones or whatever, and then apply that when it allocates it, and that's it, right? And then just return back, okay, that this maps to the cluster this way.
I still don't buy that there's any mapping to be done.
Well, there could be mapping because like an on-prem cluster wanting to access a remote bucket might still have some considerations between nodes that have access to it and doesn't, etc. Right? So what I'm saying is that the cluster topology doesn't have to be in the same language of the world's topology in the sense of cozy, not cozy, in the sense of the provider's buckets.
Okay, I hear what you're saying, but like I don't think that that's doable. I mean, I think if you tried to implement that, you would run into insurmountable problems. But maybe we just need a POC
Okay.
to show how something like that could work. Because you're positing like an on-prem cluster with two different zones, one of which prefers to use one storage zone and one of which prefers to use a different storage zone, and then some mapping needs to occur between the
Right,
storage zones and the.
and I imagine the driver is the one having the information to map it.
Well, okay, yeah. So as long as the driver is speaking to Kubernetes in the Kubernetes zone language and keeping all of the storage specific stuff hidden from Kubernetes, yes, that would work fine. Because then everyone's speaking the same language and the driver's just performing mapping internally that nobody can see.
That's what I meant. That
okay.
That the driver is the one knowing the topology of the outer world, if it's really outer, right? In the sense that there are object storage out of the cluster, but I might have two of them close by and three of them far away, or whatever preferences and etc. But the driver is the one encapsulating all this logic of how this maps into the cluster topology, and has to hide that away from the workloads and certainly Kubernetes, right?
Okay.
That's kind of.
Yes, I buy that 100%.
So with that, I feel that what you're suggesting, like using the topology from CSI, like makes sense, because that's the cluster topology. That's how CSI defined it.
I mean, that's what Kubernetes understands. And so, yeah, if there has to be mapping inside the driver to make sense of it, that there's no problem with that, as long as everyone's speaking the same language.
Fair enough. Yeah.
RPC level. Okay.
All right. Okay.
So we could agree then that we don't need region in the S3 field. The other one that we were discussing was the signature version. That one feels hokey to me, but ultimately I'm not going to argue against it.
I mean, I think it's also fair to just say that we only support the latest. Why support a compatibility mode at all?
I mean, why start with compatibility? No,
exactly.
I mean, we might end up with compatibility, but why start with it?
Right.
Yeah, it was always a concern about this hypothetical feature where there's like an S3 v5 that some workloads understand and some don't, right? And because I think we agreed that like while S3 v2 still exists, like nobody actually requires it or uses it. It's a historical curiosity at this point. Is that accurate?
Can you say again? Sorry.
S3 v2 isn't used in practice anywhere. Nobody requires it.
So I see it in the wild. I'd say, like in some compatible products, like servers which are still compatible and not supporting v4, but it's like it's beginning to phase out for sure. So I mean, unless anybody on this work group, I guess, has any restriction, supporting it in some specific fashion, we might just say, okay, so Cozy doesn't support it. You can support it otherwise, but or
Right.
with a class or whatever you want. But
Well, I think that the big question is, in a world where there is an S3 v5 that's not particularly compatible with S3 v4, would we deal with that by inventing a new protocol called S3 v5 that was different than S3? Or would we deal with it by adding a field to S3 to describe which version you're getting?
But what does deal with it mean?
To allow workloads to express a preference. In a world where I have two different providers, and one can only provide S3 v5 and one can only provide S3 v4, and the workload can only talk S3 v4 and it can't talk S3 v5, and it wants to ensure that it gets what it needs.
Yeah, or we should just leave it up to the workload to figure it out. Let's not
Yeah,
get
I
in the way there.
mean, there are probably other ways to achieve the kind of filtering that you might need in that hypothetical future. So the safer thing is maybe not to put it in. But I don't know. It just seems inevitable that there's going to be an S3 v5.
Yeah, but I'm saying we don't have to do anything about it.
the thing is, we don't know about v5 what it means, right? We don't know
Right.
if it's a signature version, if it's a API, a major API change. It's not that we have a prospect for it at this point. So
Well,
it's really hard
what we know is how v2 and v4 were different, right? That's what we know. And you can imagine that a v5 would be different in similar ways to the differences between v2 and v4.
I mean, and
so you're saying crypto will change and that's it, right? Basically.
Probably.
Yeah, I mean, it means that in order to interact with it, you need new code in your client to compute the signature differently. That's what it would mean in practice, because you couldn't just backwards compatible support it. I mean, you could support it by speaking both v3, v4, and v5. That's how you would do it.
No, I think we shouldn't get into the way between the client and the backend system. I think we should let the client figure it out.
Yeah, and let people use things like bucket classes if it really matters to them.
Right.
I can live with that.
Okay, so we're removing both region and signature version. I like this.
Removing always feels good.
Okay, so what does that leave us in bucket spec? Okay, no mind. S3 types. Let's look at S3 types. It literally just had these two fields.
Can you zoom a little bit?
Oh, sorry. Is that better?
Yes.
Yeah, this is better. We don't need these two fields.
Right, we don't need any. I was proposing that the field is literally a string enum type
I remember that,
with no sub fields at all. And if we can make that just how it works, then it seems simpler. Like where all the subfields matter is in when you're doing access granting or access revoking, or in the downward API when there's a bunch of S3 specific stuff that needs to be communicated, or a bunch of Azure blob specific stuff that needs to be communicated. But when you're creating a bucket, you're just picking from the menu which one.
By the way, GCS, does that make sense?
Yeah, like I could ask for a GCS bucket, but I would just have protocol equals GCS in my bucket request.
And then are you saying that we would have the full fields, like with the sub fields in the bucket class? Is that what you're saying?
No, I'm saying there's nothing in the bucket class,
Right.
and in the bucket request, there's just a string. And then all of these fields only matter when you're doing access. Access granting and access revoking is when the subfields of the protocol become relevant. If you're just creating and deleting buckets, you never need to look at any of these, I don't think.
No, you're right. Actually, so we can
So
get
what
it.
you're saying is, sorry, so you're saying that the bucket class determines the allocation parameters, and that's it. It's not that the request has more effect on the allocation in that sense.
I mean, it's always
Not
possible to
protocol
use opaque.
specific.
It's possible to use opaque parameters in your bucket class to control all kinds of
Yeah.
aspects of the provisioning. But from the perspective of the standard, the cozy standard, like we don't care. We say, give me a bucket that is of the type S3, and you say, okay, and you give us a bucket, and then we say, give this guy access or create an access and a BAR, and you say, okay. And then the pod wants to use that access, and then you have to supply a bunch of stuff to the pod so that it can use the bucket.
No, but but you said that the bucket access request does have to provide some, like ground base expectations. Like
Well,
you
it
said,
has to point to a BAC so that you could distinguish between like a request for read-write access versus read-only access, or those kinds of considerations. But again, like I don't know if any of those fields that we were just looking at with GCS on Sid's screen would be relevant at that point,
Right.
because those are things that are supplied by the driver to the workload. I don't know
right.
how
No,
an end user would know what those things are at the time he was requesting them. He just wants access.
Right.
that these fields seems like a driver information, not a user information,
Right.
for sure.
So the user basically creates a BAR which references a BR and a BAC, and that's it. And then a bunch of stuff gets filled in the actual BA behind the scenes, and then that stuff gets supplied to the pod when the pod starts up. But the user never cared about any of that stuff.
Right. Okay. Now there
Can
are
you
other.
can you show the BAC, the BAR, the request for access? Sorry. So I remember we discussed that as well. Like in the spec of the access request, do we still have an assertion information such that I would
There it is.
like to have right. So
you need the bucket request name. The bucket name is for that brownfield case where there is no BR. The BAC is necessary. The service account name, why do we have that? That's not obvious
Now,
to me
in
why
case we
want
want to
that.
bind the credentials to a service account rather than generate credentials.
But isn't that a decision made on a protocol specific basis? Like, isn't it the case that like if you're using GCS, you will always have service account based access?
I wouldn't
and if
even
using
say
S3,
it's not protocol specific. It's actually driver specific. Because someone S3 protocol, someone could do service account style authentication if they're inside the AWS environment, but probably not if they're inside a data center running Ceph or Minio. So it's more driver specific.
Right, but anything driver specific can't be
Shouldn't be
visible to
here.
the end user, right?
Fair enough. Yeah, no, I agree.
Yeah.
I'm on your side. Okay, so we can actually get rid of this.
Well, I'm not 100% convinced that the GCS scheme is going to work without this, but yeah, my instinct is it probably shouldn't need it. The question is how.
Yeah, GCS can work with just access key and secret key.
No, but like if you want to
the
do
pod itself will define it, right?
Right, but it's too late at that point, right? Like if you've created a BAR and it's not bound to anything, then there is no service account to set up. And
there is no service
account
to set up because it's already set up.
There's no service account that can be referenced at the time when you're trying to grant access, because after after when the BAR gets created, some sidecar is going to see that, and it's going to see a BA that needs to be completed, and it's going to go talk to the driver and say grant access on this bucket to this thing. And then after that is completed, Kubernetes has to have all the information it needs to actually start a pod and connect to that bucket. And so at that point, you don't know what the service account is yet, right? Because it's service account will only be chosen by some future pod that will be created by the user after the BAR binds. And so I do see an issue with, if you really wanted for the access to be bound to a service account, that you kind of need to know what it is before the pod is created. But then it's
In order
what makes it
to what?
weird though
To
is
add permissions, you mean?
No,
If I need to add permissions?
in order to create the pod with a service account, you need to specify it while creating the pod spec.
well,
And
but you have to create the BAR before that.
right.
And if so, you don't have a pod at the time you're creating a BAR. And the
But
issue
what does a BAR care about the service account? Should it add permissions for the service account or do something with it?
Because the creation of a BAR is going to cause the driver to get invoked with a grant access request. And so the driver needs to know which thing to grant access to when it goes and talks to the actual backend, the actual storage controller. And if you're not told at that point which service account should be granted access, then I don't know how you would even implement that. So,
no, but in the case where you're not using service accounts, then you're not told as well.
right. So if you're doing access key and secret key, service account is irrelevant. You generate those on the back end side and you hand them back to Kubernetes, and then Kubernetes just gives them to the pod uses them, and you're good to go. But yeah, if you wanted to do it through the service account, it messes up the pattern, because you have to know the service account at the time of granting access, not at the time of use.
Right. So you need to know who to grant.
Right, and that's basically why I think it's in here. But it feels awkward because it matters for some protocols and not for others, and that's hard to document. How do you document, like, you need to use this field if your particular bucket protocol is one that uses service accounts for authentication, but if you're using one that doesn't use service accounts for authentication, you can leave this blank. Like, that's horrible documentation.
Again, it's the driver, but yeah.
Well,
I would actually get rid of this because this actually causes more confusion, and also the design gets weird.
But if we get rid of it, we need to be able to answer the question of how would we ever do service account based authentication for Azure and GCS.
We'll figure it out after alpha.
Okay.
Yeah. Yep. All right. So, okay, getting rid of service account and then getting rid of protocol specific structures and just having an enum, like all of this so far. There's something else that was in my mind. Okay, so there is one other thing. While requesting a bucket, you can specify bucket specific parameters. So let's look at GCS create bucket API. So there's a bunch of options you can set. Let me see. There you go. Buckets. Let's see. This is to write into a bucket. This is with objects. Oh, okay. This is get insert. Would that be create bucket?
Sid, we have like 4 minutes, and I just want to ask you, do you think I think we are trying to close on API as much as possible, right? And so and every time we kind of jump to the spec, which is like the main pieces of the APIs, we keep on adding more questions and making more changes, and I would like from the point of view of this work group, right? Maybe what we should do is like go over these spec structs one by one. Like, you know, there isn't too many, right? There's like four,
Sure.
and just see that we are content with this
You mean at a high
model.
level, the full picture?
Yeah, I guess so. I mean, there's always like, you know, deep dive discussions in every field that we get into discussion of. But like, you know, we really want to get the API review done, right? That's like the main goal for this project to get going. And we seem to be, you know, going in our circles around these specs, you know, making these changes and back, thinking about it again, which is perfectly normal, of course. But I think maybe we can try to do an API review internally first, like something, you know, go over these APIs, say, okay, we are fine with this, we're not fine yet with this, you know, have a list of gaps, and then try to close it down, because feels like it's like going it's
In
like getting
circles.
farther away from us, right?
Well, so you know, I'm at least you know, I have a view of the big picture, um, and you know, one good way to you know, get the big picture right is um, actually to just keep solving problems one by one, because eventually we'll get to the right point. Um, so that's the kind of approach that I'm just following
Fair
here.
enough.
But I think you make a good point. Let us do an internal review, and let us look at the whole thing as one, um, because not everyone solves problems the same way, and you know, maybe there's a perspective I'm missing, and you know, we can add it. You know, you can help make it better. So I'll do that, diagrams and a full picture of what the APIs look like, and we can go from there. Would that help?
Yeah, I mean, I think so. I think I keep on seeing these specs in the discussions, you know, being discussed to be changed, but I'm not really sure if
I'm not. Yeah,
we're following up, right? And I'm to be honest, I'm not onto it, right? I'm
I
mostly
see.
involved in the discussion, so I don't know what happens in between. So yeah,
Oh yeah, we're
it's not
definitely
a
making the
criticism
effort.
in any way.
Oh no, not at all. I don't take it that way either. So we're definitely following up, and we're taking out fields that we don't need. I don't think there's been a time where you know, we've talked about something and we've come back and then solved the same problem the second time, um, because we follow up right away. We have some people actively writing code. It's just things are still in flux because there are still some unanswered questions, and you know, service account was a good one, for instance. And I think last week or 2 weeks ago, this question about protocol came up, and you know, we wouldn't be discussing it if it wasn't something that you know, if it wasn't a sensible question. So um, the way I
No,
look at it,
every question is just about. Yeah, I
fair
agree.
enough.
We're
Yeah,
just moving in between how to scope this first release. I think we're like once
right.
at one time we're saying this is a must, and at the second time we're saying, well, we're not sure, so we can drop it, right? So, and then we add it back again in some other form of a
I see.
class, or you know, I think we are doing you know, what do you call that, like a converging series of changes. I'm not saying it diverges, but
Mhm.
um,
Like service account, for instance,
yeah.
yes. It also you know, is a function of the people, the actors in the group, as in you know, some concerns are more important for some people than others. It's just service, and everyone's concerns are important to me. Now, service account was something that Andrew from GCS brought up, and it's a very important concern, but we don't have a good answer yet, and that's why I'm okay with saying we'll do it later. um, this was an unanswered question all along. It was never something we figured out you know, in its entirety. So you know, I
Right.
would say, yeah, I would say, you know, looking at the full picture, maybe I should do a better job of communicating it, but we're definitely converging, and I don't think we're throwing things, we're bringing things into scope and out of scope just willy-nilly. I don't think so. But something might have escaped my view, and if it did, do let me know. But otherwise, I think we're definitely getting to the right point.
So do you think these discussions help with passing on the API review then?
So the API review is like a step that follows having a good design. So getting the design right is far more important to me. I know we're all focusing on getting the API review correct, uh, but if the design isn't right, it doesn't matter if the API review deadline is reached or not. So that's what I'm
Yep.
focusing on, without
Okay.
putting the artificial pressure of the deadline. And to be honest, as long as we go in the right direction, we'll get through the API review.
So the one tool that we use a little bit sparse is scoping. We sometimes use scoping more aggressively, and sometimes we're not. It's we keep on discussing things which we are not sure we are going to use specifically in the group that discusses it. And like in the case of service accounts, right, we're saying yes, if Google were on in this discussion, we might have a real discussion about it, but like for now we're just doing a discussion on their behalf for what they might want and might not, and then we scope it out, and
Yes,
that's
since
kind
they're
of
not
where
here.
yeah.
No, since they're not here, look, so they need to be here for us to understand it more, or come up with a solution. Since they're not here, we're just putting it off for later.
Okay.
Yeah, they need to be here. So,
Okay.
I mean, this is where we discuss, and they're aware. Andrew is aware. So, I could personally go and talk to Andrew and ask him to join us again, at least for the next few meetings. But that's the reason.
Right. The thing is that once you know how these things work, right? Whenever you get to the end line of the review, you find that somebody's not like was involved in all the stages, and now doesn't get the level of control that was desired for it, for his needs, but and can affect that. So I guess that I don't have a solution. I'm just saying that
That's a fair point. Yep. It's
I'm just
happened.
saying. I mean, yeah.
It happened the first time it happened quite a bit. The second time we got through it, but this time I think it'll be even easier. So yeah, when people came in the last minute just to review the KEP rather than participating in the discussions, they did bring up concerns, but we addressed them the first time, and then the second time there were a smaller set of concerns, and this time if something comes up, we'll address them again. I don't have a I mean, like, if you're not participating actively, we can only do so much that satisfies your needs. Now, I think we should go forward with what we have, and if concerns come up, we deal with them one by one. I don't see another way, because if you're not participating in the group, it's hard to know what you need.
Yeah. So I'm very happy with these discussions. I mean, I participate every time because I feel very engaged, but I'm also concerned a little bit that it's still in the discussion, and we can't get like the first API approved or something. That's kind of something that I personally I feel well, maybe I'm a little impatient, like in that sense. Maybe it takes more time, but anyway. Yeah,
No, it's a good
that's
thing.
kind of
What you're bringing up is a good thing. Yeah, vendors being impatient is the way we can actually move this forward. It's a good thing. I would say let's push it again together. Like API review is something. The way I look at it is it's something that should not affect the actual discussions that we have in terms of scope, because API review I mean, like, what we need for alpha is pretty much where we are already. Any discussions going on further is post alpha. That's how I look at it. And you can't hold back these discussions because API review isn't complete. Now, if there's a particular concern that's raised, then we can discuss it here, but we haven't gotten there yet. Like
I
topology
think it's
discussion.
still, I just think it should still have a like a timeline, right? So I think I think it's really time to submit a cap and that team to start reviewing again.
Fair enough.
Because we still saying, are we still saying we are targeting 1.22 or not?
We're definitely
Okay,
saying
I
that.
think we definitely should get started next week. It's already cold freeze next week.
Right. I think what Guy was bringing up is we don't have a clear picture of the scope, and also like how we're deciding to have something and how we're deciding to push something for later. That's a very valid concern.
Yeah. And I'm pretty open to have everything up for later, assuming like we just know how to go about it later, and we feel confident enough that the base design is good for the basic feature. But yeah, I completely trust your process, the process that you're taking this through, and I appreciate it. Of course, I would be happy to be involved in any review process or anything like that. If I just think if you highlight the gaps that you want us to discuss, I think it will be even more efficient for achieving that. That's kind of what I was trying to.
Yeah.
Thanks.
Yeah. Thank you. Yeah. Thank you. Right now, the way I look at it is the KEP itself is on me, and depending on feedback, we'll have things to discuss. But as of right now, we should just keep moving forward, and having these discussions, because the momentum of the group also matters. And any problem that we see as a potential problem, we should discuss. There's one thing that I would appreciate help on, which is development. We need more people testing out or writing prototypes of all these designs that we come up with, because while writing code, there'll be some things that's discovered that might have to be addressed.
So I know we're way past our time, and I wanted to agree with what you said, both Sid and Guy, and just really briefly on the point that you started, Sid. All of that stuff that you can specify at create time, I'd say those are BC opaque fields, and leave it at that.
Okay.
And yeah, we don't need creation parameters in a